Hello everyone. I want to discuss the procedures for the upcoming lab iron in vitamins. One thing I would like to say before we get too far into this is that this will be a much more complicated lab than what we did the first in-person lab meeting where we were doing a titration. There's a lot more involved to this lab. So if you found the titration lab a little bit difficult, you might need to spend additional time reviewing this guideline before coming to the lab to do the experiment. There's a lot more involved here. This does involve things you perhaps did not see in the first semester of general chemistry, whereas the titration should have been something you had seen before. So this is new. There's a lot of steps. You need to do them in the right order. If you do them in the wrong order, things are not going to work out very well for you. It is a 2-week lab, but for the first week, there's still a lot. So this discussion today will be mainly over the stuff we'll be doing in the first week of the lab. A little bit about the theoretical background. You'll need to be discussing this in your report. This is the lab you'll be doing your formal report on. You will be doing what's called serial dilution. So you'll be taking a sample, diluting that, and then diluting that sample again. And you'll do that a few times. And you will need to be able to do the conversions to arrive at the right concentration for that. In some cases you'll be converting in one direction, in some cases you'll be converting in the other direction. So there's a little bit of math there. You want to be familiar with the dilution equation and applying conversion factors. So just be aware of that. And then also we'll be using Beer's law. We introduced this in Chemistry 1A. You may or may not have had a chance to actually do spectroscopy in Chemistry 1A, depending on when your Chemistry 1A was shut down, if you were taking it in the spring, that is. So this will be a chance to do this. We're not going to go through the details of Beer's law right now. And this part of it you'll actually will not be performing until the second week of the lab. So today we'll be discussing the sample preparation. Next time we'll talk about the spectroscopy and analysis. When I say today, I'm referring, of course, to the first day of the lab. You may be watching this prior to the first day of lab. That's fine if you are, but just be aware. When I say today, that's what I'm referring to. So there's several things you'll need to do on this first day. You'll need to prepare the vitamin tablet and prepare the standard dilutions. You will be doing a lot of moving solutions from one container to another as you're doing these dilutions. You'll need to make sure that each of your pieces of glassware is very clearly marked, so that it is easy to come back to those later. So make sure, again, everything is marked very clearly for your glassware. And then we'll talk about the dilution procedures. And I think how we'll do this is when we get to the first time we do it, I'll talk through the details of how that works. So the first thing you'll be doing is extracting the iron from the vitamin tablet. So in order to do this, you will crush the tablet with a mortar and pestle. These will be provided for you. Here's an example of what these will look like. So you'll crush up the tablet. Make sure you get it into kind of a fine powder. And then once you do that, you'll transfer that into a beaker. Make sure to wash your mortar and pestle so that any of it that may be stuck on there is being transferred. You want to get all of that powder into the beaker from the mortar and pestle. So use as much DI water as you need to get that to happen. You'll be heating that for 15 minutes in 6 molar hydrochloric acid. So there are a few things you need to be aware of with that. The hydrochloric acid, of course, is very concentrated. It's a strong acid, so it is quite dangerous. So be very careful handling that. Cover it with a watch glass and perform this in the fume hood. Make sure you're monitoring this as it's occurring. You don't want it to boil over and spill out. So you are going to be doing this as an individual project. So you will be responsible for monitoring that yourself. Once you have done that, you will need to filter the solids from the solution using a filter funnel. I'm showing a picture here of a typical filter funnel setup where you have the ring stand, this time with the ring on it instead of the burette clamp. So you know where to find the ring stand now. The ring for that should be in that same drawer. You'll put your funnel in there, and then we're showing here a beaker. You want to actually be transferring this into your 100 milliliter volumetric flask as you're doing this step. And then there will be a separate video on how to prepare the filter paper to put into the filter funnel. I didn't bring any filter paper home with me, so what I will do is I will share an internet video someone else has prepared on how to do that, and it will be something you can find in the same place where you find this video. So you'll completely transfer into the 100 milliliter volumetric flask. One thing to be careful of here, I said use as much DI water as you need to. Don't use over 100 milliliters because we need to have the flask, we don't need it to be over full. So don't use more than 100 milliliters as you're rinsing through the various steps here. So transfer into the volumetric flask. It could be at various stages, but you want it to be below this etched mark. If it is not, please come and ask me, and we'll have to figure out a plan for you on how to proceed from there. So you want to fill up to the mark with DI water. So it might be somewhere down here, somewhere around here. Add DI water until it's exactly on the mark where the meniscus is the bottom of the meniscus is touching that mark. Once you've done that, put the lid on it and shake it 30 times. That will ensure complete mixing, so you don't have maybe more of something on the bottom, less of it on the top. The whole thing is mixed up equally, and you can take a sample out of it and it will be a representative sample of what's in the entire container. This is going to be solution 1, and we'll continue by doing something to solution 1 in the next step. Okay, so the next series of steps are going to be what we call serial dilution. So what we do here is we take a very concentrated sample, which the what you got out of the iron vitamin is a very concentrated sample, and you're going to dilute that down and dilute it down again and again, so that we have a sample that works with Beer's law. We want it to be within a specific range in order to have a linear trend there, and we'll talk more about that next time. But that's the reason why we're doing this. We're not just doing it to make your life hard. There is an actual reason for this. So we're diluting the solution further. When you do this step, you will be using, instead of a 100 milliliter, you'll be using a 50 milliliter. So you go from a 100 to a 50. So what you want to do is you want to pipette out 2.5 milliliters of solution 1, transfer that into this second volumetric flask. So a little bit about how that works. You'll need to use a pipette and a pipetter. So for your case, you're doing 2.5 milliliters. We're showing some kind of specific amounts here where they have an etched mark like we're seeing on the volumetric flask. There isn't one that we have for 2.5, so we will be using a graduated pipette for this. So how this will work, let's say you do a 5 milliliter maybe you're doing a 5 milliliter pipette, what you would do, you would fill it up to the top, so that's 0, and then you would drain it down. So you drain 1, 2, 2.5. So you go from 0 to whatever the amount you're using, in this case 2.5. How these pipetters work, you'll get this green pipetter. You'll put the pipette in the bottom. You want the pipettes have a tip on one end, and they have a kind of a wider barrel on the other end. You want to put the wider barrel in here, not the tip. And then you'll put the tip into the liquid you want to take a sample of. You want it to be well below the surface of the liquid. And then you'll depress with your thumb this kind of turning knob, and as you press that, it will suck the liquid up into the pipette. So you'll suck it up. You'll want to get it up to kind of the 0 mark, and then you'll move it to the volumetric flask you'll be adding it to. Yours will be not 100 but a 50. And then you'll turn the thumb knob, you'll turn it the other way, and it will gradually add. And you can kind of see, you can kind of calibrate that with your thumb. You can see how, as you're turning that, it's going to add slowly. And you want to add right till you get to the amount you want, which is 2.5 milliliters. Okay, so that's how you use these. We'll be using these a lot in this lab. So this is the first time we'll see that. So you'll do that. You're adding a very specific amount of your solution 1, and then again you dilute up to the line by adding DI water. Again, shake it 30 times. This is solution 2. We need to analyze this solution to know how to continue with the preparation of the solution we'll be testing. So to do this, we'll take out, once we've shaken it, it's completely well stirred, take out 5 milliliters of this solution. Same pipetting skills that you've been using, but here use a clean pipette. Don't use the same one you just used, because that one you had added from the other one. If you need to clean it out, you can. One thing you can do is, if you are needing to reuse the same pipettes, if you run the solution through that you're using, that will be better than just cleaning it with water. So maybe clean it with water first, and then clean it with the solution that you're using. So you'll remove the 5 milliliters, add the methyl orange to that 5 milliliter sample. That's an indicator. So we're seeing here how it will change color. So you should get a red solution at first, and then you'll add some sodium citrate. So add 1 drop at a time. Count the number of drops. So count the drops as you add them, and then when you see the color change, so when you see it change kind of orange, go ahead and stop, and that is as far as you go. That there is a little bit of subjectivity to that color change, so just be aware of that. But you want to be consistent. We'll be doing the same thing in a little bit with another sample. So count the drops, keep track of how many drops that was, because you'll be using that in the next step. Okay, so one more dilution here of your sample you're going to be analyzing. That's preparing solution 3. So again, we'll take 5 milliliters of solution 2, and we'll put that into a 50 milliliter flask. And then we will add to that flask drops of sodium citrate equal to what you had already done. So when you counted the drops in the previous step, that's how many drops you want to add. Same thing. You're adding the same thing, sodium citrate. You are not adding methyl orange. Do not add methyl orange to this solution. That will lead you to incorrect results. Okay. There are some additional chemicals you'll be adding here. You'll add a milliliter of hydroquinone and 1.5 milliliters of orthophenanthroline. You don't have to know how to name or spell those. They're just the chemicals we're using to help with this analysis. For this step, you can use a disposable pipette, so we're showing what those look like here. These are not as accurate, but these are simply things that help with the process. They're not the thing that will be producing most of the color that we'll see. You do first the 5 mils of solution 2, the drops of sodium citrate, add those two things, and then we dilute up to the mark with the DI water. So make sure you're adding all 4 of those things first before you dilute to the mark. Again, you'll do the same thing where after you dilute it, you'll shake it 30 times so it's well stirred. This is what we'll be analyzing. You will not do the analysis today, but if something happens where you have to prepare some of this the day we do the analysis, it does need to set for about 10 minutes for the color to fully develop. So you will need to wait that time when you are preparing it. Go ahead and keep solution 1. You might even keep solution 2 in case you need to restart some part of this for some reason. Hopefully that doesn't happen, but there have been cases where people wish they had those around and they didn't. So this is what you'll be analyzing for next time. You need to get at least this far in the lab on the first day. The additional thing we'll be doing is preparing the standard dilutions. So these are the standards we'll be comparing your sample to in order to determine what its concentration is. So we have a 5, we have a 40 ppm stock iron solution, and you'll be pipetting 5 milliliters of that solution and into a beaker. Adds methyl orange to this stock iron solution, should turn red as we've seen before. Again, add sodium citrate, count drops until it turns orange. So this is the same thing that we did with our sample. You'll be taking the amount that you added here to figure out how much of the sodium citrate to add to your standard solutions, which we'll be preparing. So this is basically the same analysis we did before for the solution that we'll be analyzing. We're doing the same thing for the standard. Okay, so let's talk about preparing the standard. So we'll start with standard A. So you'll pipette 5 milliliters of that stock iron solution into a 50 milliliter flask, and then you'll add your drops of sodium citrate that are equal to what you just calculated or what you just counted with the methyl orange. We're not adding methyl orange this time. We're only doing that as an indicator for deciding how many we needed. We'll then add those additional chemicals, the hydroquinone and the orthophenanthroline. Again, disposable pipettes are fine. This is the same process we use to prepare your sample, your unknown sample, we're doing to prepare the standards. So starting with standard A. We have 4 more standards as well. So we had standard A, we'll have standards B, C, D, and then the blank. Before you prepare those, you'll need to figure out the relative proportion of the sodium citrate that you'll need. Okay, so however many drops you needed for the 5 milliliter sample, you'll need a proportional amount for your other samples. So we're showing an example here. So whatever you needed here, let's say you needed 30 milliliters, or I'm sorry, not 30 milliliters, 30 drops. You needed 30 drops of sodium citrate for 5 milliliters. If you had 30 milliliters, you'd have to figure out X. How many would that be? So if we take 30 divided by 5, that's 6. So 6 times 3 is 18. We would need 18 drops. So that's how you would decide that. Maybe it's not 30 drops. Maybe it's 20 drops. And then you do the same thing. 20 divided by 5 is 4. 4 times 3 is 12. So you'd have 12 drops. So you would do that process for each standard, B, C, and D, based on the volume of the volume that you'll be using of that standard, of the stock solution for that standard. So you'll need to do this calculation each time. Same thing as before, you'll add those other chemicals, those other two chemicals, you'll do the dilution the same. These will all be in 50 milliliter volumetric flasks. One thing I should tell you is that we might have a shortage of these flasks because you are all working individually. So as you're preparing these, you might have to, you prepare a sample, transfer it into a beaker, and then reuse a flask for a later standard that you're preparing. So you'll do A, B, C, D, and then you'll prepare the blank. In the blank, you have everything but the iron solution. So you add everything, but you don't add the iron to that one. A little bit about safety. There are definitely some safety things to be aware of here. So be careful with handling the hydrochloric acid. It is very concentrated, as well as the orthophenanthroline. So I would recommend wearing gloves for handling each of those. When you're heating the acids, do that only in the fume hood. Don't do it at your lab bench. Anything that has the orthophenanthroline in it should be disposed of in the organic chemical waste. So we have a separate waste container for that. We also have an aqueous waste container. So anything that does not contain orthophenanthroline can go in the aqueous waste container. I will point out to you where these waste containers are located in the lab when we start the lab on Wednesday. So next time we'll complete the analysis. So you'll do the spectroscopy. So you prepared all your samples for that. And then the calculations, you might have to potentially redo something. And we'll see how it goes. And hopefully you're able to prepare all your samples in this first day. If you need a bit of extra time to prepare your standards, that might be possible, but I want to make sure we'll check in at the end of lab. So don't leave before you have everything completed. Again, this is the lab we'll be doing the formal report for. So you do want to make sure that you are getting some good data so you'll have good stuff to write about.